All right, we got cut off because I was in a conference room and Mr. Cerrone needed to put something in here. Where were we? We were talking about scaling triangles, so no sides are equal. So you'd have, and like this is an example over here, none of these three sides are congruent. None of those sides equal each other. Our next way that we classify by side is isosceles triangles, where you have at least two sides that are equal. So an example of that would be this kind of triangle. I'm going to show you that those two sides are equal by using those little dash marks. And then the last one would be an equilateral. So in this one, all sides are equal. And here is our little example for that. Okay, it's not drawn perfectly, but you get the idea. Equilateral and equiangular, kind of popping back up here, equiangular and equilateral. Those have to be the same thing. In order for a triangle to be equiangular, it has to be equilateral. In order to be equilateral, it has to be equiangular. So if you know one, you automatically know the other. All right. When we are actually classifying triangles, we want to classify by both angles and sides. It's not fully classified if it's not classified by both. So over here, I see I have 90 degrees, so that is one right angle. So I know I'm dealing with a right triangle. And they're telling us that no sides are equal, so this would be a right scaling triangle. And that's really all there is to it when we're classifying. Let's try another one. Again, I need to classify by angles and sides here. So I see that I have two sides that are congruent. So I know it's isosceles. And I see that all three of these angles are less than 90 degrees. So I am dealing with an acute isosceles triangle. All right, we have a few more definitions here. At this point, we should be back in our regular notebook. So this table should go in your comp notes. But any of these examples, that should be back in your regular notebook. So make sure that you're back in there. That's where we're going to put the rest of these definitions. So we call the three original angles of a triangle the interior angles of that triangle. So over here in this diagram, we can see that angle 1, angle 2, and angle 3 are interior angles. The angles that are adjacent to the interior, again, remember, what does adjacent mean? It means that you have two angles that are sharing one side. So if this is angle 1 over here, well, angle 4 would be adjacent. They're sharing a side. We call those exterior angles, all right? So basically, where are your angles that are inside your triangle? Where are the angles that are outside the triangle? Oftentimes, because we're dealing with a vertical pair here, right, angle 4 and angle 5, oftentimes we just simplify our diagrams to look like this and just show one of those exterior angles. Again, this would be because angle 4 is congruent to angle 5. Because of the vertical angles theorem, we tend to just show the one exterior angle. All right, here is our first theorem of the day. So theorem 411 is our triangle angle sum theorem. You guys have already used this, okay? All this says is that if I add up my three angles in any triangle, they're going to equal 180 degrees. So for example, you might have a problem that looks something like this, where I'm going to tell you that this angle is 50 degrees and this one is 62 degrees, and I'm going to ask you to solve for x. All you're doing here is just adding these up, setting them equal to 180 degrees. That's going to give me 112 plus x equals 180. I'm going to subtract the 112, subtract the 112. I know that x, that angle, is going to be 68 degrees. Okay, so you guys have kind of already done this with some problems, but here's the official theorem. I think someone a week or two ago was talking about like some of these theorems, we just know them. Well, yeah, but in order to prove something more complex, I need to use all of these agreed upon true theorems that someone at some point discovered, found to be true in every single case, and now we just kind of take them for granted. But you might need to use this theorem to prove something that's way more complex. All right, here's a corollary. So this is the first corollary we're dealing with. A corollary is just a special name for theorems, special name for theorems that are easy to prove directly from another theorem. All right, so because I know theorem 4.11, I get corollary 4.12. It kind of follows directly from another theorem. So directly from another theorem. Okay, this corollary states the measure of each exterior angle of a triangle equals the sum of the measures of the two non-adjacent interior angles. Okay, so non-adjacent here. I know that this angle right here would be adjacent to angle 1. So I'm not going to include that one. I'm going to include my two non-adjacent ones, angle 2 and angle 3. I know that this has to be true, okay? And you can kind of think about this in a few different ways. Well, if I know that this angle and 2 and 3 add to 180, and if I see that this angle and angle 1 right here are a linear pair, well, I know they must both add to 180. So it kind of follows using like a substitution property that this angle 1 would have to equal angle 2 and 3. Let's do an example to kind of see this at work. So here is our diagram. I'm going to tell you that this angle is 110 degrees. I'm going to ask you to solve for x. This one is 30 degrees. Setting this up with our corollary, we would say 110 equals the sum of my two non-adjacent angles. I would subtract 30 from both sides, and I would get that x equals 80 degrees. Let's kind of prove this out to ourselves. If I just asked you guys for this angle, well, you might recognize that I'm dealing with a linear pair here. So 110 plus this question mark would have to equal 180, which must mean that this angle here is 70 degrees. Well, now I could see x would have to be 80 degrees if I have 70 plus 30 plus x equaling 180. So you guys kind of see how we're using what we know about like linear pairs to kind of create this corollary and what we know about adding up the angles in my triangle to 180. So that's how you would tackle this corollary. All right, another corollary for y'all. Two acute angles of a right triangle are complementary. So again, with this one, it's a corollary because it's derived directly from theorem 4.11. If I know that all three of these angles have to add to 180 degrees, if I already know that one of them is 90, well, that makes sense that the measure of angle 1 plus the measure of angle 2 would equal 90 degrees. So sometimes you'll see a problem like this, where you're dealing with your right angle, they're going to give you one of those angle measures, they're going to ask you for the other one. Instead of adding all three of these up to 180, you could just directly jump to x plus 60 equals 90, which must mean that x is 30 degrees. All right, that's really all that we're doing with those corollaries. Okay, here's another type of example. Use the triangle angle sum theorem, so that's our 4.11, to find the measure of each angle in the given triangle. So here, instead of just numbers, they're including some of these x terms. We're just going to do what we are told to do with that theorem, which is add all three of these together and set it equal to 180. I'm going to combine my like terms here. So I'm going to get 26x plus 24 equals 180. Subtract our 24. We're going to get 26x equals 156. Divide by 26, divide by 26. I should find out that x equals 6. Okay, am I done with my problem? I know what x equals. Well, no, they're asking for the measure of each angle. So at this point, I would take this 6 and I would plug it in. So I know that that 5x angle is going to be 5 times 6, or 30 degrees. I know that 6x angle is going to be 6 times 6, or 36 degrees. And I know that last one, 15x plus 24, is going to be 15 times 6 plus 24, which would equal 114. If you ever want to double check these numbers, so these are your answers right here. If you ever want to double check those answers, just make sure they add up to 180. So 30 plus 36 plus 114, yep, they add up to 180. We are good to go. That's what we're looking for. Alrighty, we are nearing the end here. This is your last example. Here they're asking us to use that exterior angle of a triangle corollary to find the measure of the exterior angle and the non-adjacent angles shown. So what does that corollary tell us to do? Well, it tells us to set my exterior angle, lost my pen, equal to the sum of my two non-adjacent, x plus 67. At this point, I would probably add over that 53. That's going to give me x plus 120 over here equals 3x, and I would subtract that x. So I'm getting 2x equals 120, which means x must equal 60. Okay, so that tells me this angle right here is 60 degrees. And then I would need to take 60 and plug it in for x over here. That would give me 3 times 60 is 180 minus 53. That's going to give me 127 degrees. So that's what this angle right here equals. Again, double check yourself. Does 60 plus 67 equal 127? It does. Okay, cool. You're done with the problem. All right, check back on Classroom to see what else you have in your assignment for today. See you guys tomorrow.